Hi class. So in this video, we're going to follow up on our previous video, and we're going to show some examples using nested for loops and multi-dimensional arrays. And I'm going to start with looking at the following problem. Okay, so let's look at a multiplication table. We want to compute this. We're going to write a program that creates this. Okay, and effectively what the program's going to do is the user is going to type in the number of rows, and we're going to assume it's always square so that the number of rows equals the number of columns, and we're going to compute a multiplication table such that if we multiply, for example, the row and the column number, that we're going to get that will define the value of the cell in the table. Okay, so I'm going to show you the code for this, right away, and then we're going to trace it. I think that will probably be helpful to look at this from a couple different exercises, a couple different viewpoints, from kind of doing the code, going through it and actually building it versus showing it and tracing it. So let's trace the code that defines this. Okay, so we're going to have the user type in the number of rows. Let's assume that the user types in 5. Okay, so that rows has the value 5. Okay, you know what? I take that back. Let's make it a little smaller. Let's assume that the rows is 3, just so we have a nice small number to work with. Okay, and I'm going to look at the trace a couple of values, I and j, and we could also call these like row and column, right? I mean, it's the same idea. I just gave them names, row and j. And to make this easier to compute what's going to happen on the console, notice that we started these loops with, we initialize them to 1, and we're going till they're equal to rows. Okay, and since it's square, we don't have to ask the number of columns. We're going to say that the number of columns equals the number of rows, so we're going to use one variable to define that. Okay, so let's trace this out, and I'm also going to trace what we're seeing on the console, what we're seeing on the output screen. Okay, so when we hit the outer loop here, we see that I gets initialized to 1. Okay, and I is then less than or equal to 1 is less than or equal to 3, because 3 rows is 3. And then we enter the inner loop here, and j gets initialized to 1. So we're going to initialize j to 1. Okay, 1 is less than or equal to 3. And then we're going to print I times j. 1 times 1. So we're going to print 1 to the console. Okay, and we're also going to print a space. Okay, notice there's a space after the format specifier here. We then increment j. J is 2. 2 is less than or equal to 3, because rows is 3. Enter the loop again. Now we're doing I times j again, 1 times 2. So we're printing 2 in space. Okay, go around again, increment j. 3 is less than or equal to 3. That's true. We're going to enter the loop again, and we're going to have I times j, which is 1 times 3. So 3. Okay, and at this point, j gets incremented to 4. 4 is not less than or equal to 3, and we're going to leave the inner loop, and we're going to print a new line character. So we're going to have a new line here. Okay, so that we go to the next row. Okay, the next row. So we could have called j columns, or c and I r for row if you wanted. It's whatever names you want to give these things, right? But then we come up here now. We're going to go back up to the outer loop, right? We're going to increment I. I becomes 2. 2 is less than or equal to 3. Okay, I becomes 2. We enter the outer loop, right? We're going to go into the body of the outer loop, and then we're going to hit the inner loop again. And the key thing is we're hitting it again. So we're going to have j is going to get reset to 1. So j is going to become 1 here, right? And we're going to now iterate the inner loop again, which is effectively going to count 1, 2, 3, right, inside of it. So we're going to We know that when the inner loop runs, it's going to go 3 times, right? It's going to count j as 1, 2, and 3. When j becomes 4, it's going to leave and not enter the body of the loop. Okay, so for each one of these times that it iterates through the inner loop, we're going to have I times j, and we're going to print that out to the screen. Okay, so we're going to have 2 times 1, right? Then 2 times 2, and then 2 times 3. Okay, then we leave the inner loop. We print a new line character. Okay, we come up here. We increment I again. All right, 3 is less than or equal to 3. Okay, we're going to come back here and we're going to hit the inner loop again, where we're going to reset j back down to 1. And again, it's going to count 3 times. Okay, and now for each time through, it's going to say I times j again. All right, so we have 3 times 1, okay, 3 times 2, and then 3 times 3. Okay, and then the new line character. Okay, and then when I increments to 4, 4 is not less than or equal to rows. Okay, and we're done. Then notice when we do this, this is what was printed. We have our multiplication table printed to the screen. Okay, so a couple things I want to note about this is if we ask the question here, how many times does this line run? Right, something that's inside the body of the inner loop, assuming that these loops are defined to run the same number of times each. Okay, that's going to be that will run. Okay, row times, right, or row squared number of times that this line will actually execute. Okay. Row squared number of times. Okay, oftentimes people represent that as n squared, where n is the size, right? In this case, the number of rows. If it was rows and columns, right, it would be running row times columns times, right, inside the body of the loop. And that's an important thing to note, because it allows us to know how, when we're looking at a table, this kind of nested for loops is really good for walking each element inside of a for loop, each element inside of a table. Okay, to make sure that we're hitting every cell one time. Okay, now if I wanted to do this where I'm storing this here instead of to the console, if I wanted to store this information into an array, I could absolutely do that, right? If we look at this code here and we change it up a little bit to be able to store it as a 2-dimensional array, well, I would just add here, I would have to declare the array. Okay. So now we have that space reserved. And then down here in the loop, somewhere in the body of that inner loop, I would have to say the array, okay, I j equals I times j. Okay, that will cause this array to store the multiplication table. So instead of printing it out to the screen, if we wanted to actually store it in the computer's memory so that we could retrieve it later, we could certainly do that with some minor changes to this code logic. Okay. All right, let's do one more example. Let's imagine that we wanted to do the following. Okay, the loops are going to look a little bit different in this case. Let's imagine we wanted to build this asterisk pyramid so that the user enters a value like the number of rows, and in this case what we're going to do is we're going to print out the number of we're going to have an asterisk on row 1. We're going to start counting at 1 in this case. Okay, At row 1, we're going to have 1 asterisk, and row 2, we're going to have 2, row 3, 3, 4, row 4, 4, and so on. And we can have this be any number we want, right? It'll change dynamically based on the user's input, okay? All right, how would we go about doing that? Well, again, I'm going to show you the code, and we're going to trace it, okay? I'm going to show you the code, and we're going to trace this out. All right, so here's the logic. And once again, as you probably imagine, that this is built using nested for loops. It makes it way easier to write the logic to get this to work. Okay, so I'm going to trace this, and I'm going to trace, once again, I and j, and then also what is printed out to the console, what is printed out to the screen. Okay, so we're initializing here I to be 0, okay, and j to be 0. I and j to be 0. And then we're saying, okay, if j is less than or equal to I, well, they're equal, right? 0 is less than or equal to 0. So we're going to enter here, and we're going to print 1 asterisk. Okay. I increments, 1 is not less than or equal to 0. So we're going to leave the inner loop. We're going to print a new line character. Okay. Come back around. We're going to increment I. Okay. Then we hit here, we say j is 0. We're going to reset j back down to 0 again. And we're going to say, is 0 less than or equal to 1, right? Is j less than or equal to I? Yes. Print an asterisk. Okay. Then we're going to increment j. Okay. And then we're saying we're going to hit the condition again. We're going to say is 1 less than or equal to 1? Is j less than or equal to I? Yes. Print another asterisk. Okay. Then j increments to 2. 2 is not less than or equal to 1. So we're going to leave the inner loop. We're going to print a new line character. Okay. Come back around. We increment I. Okay. And let's imagine for the number of rows here, I'm going to say that we imagine the user entered 3 just to keep the numbers kind of small. Okay, but I now is still 2 is less than 3, so we're going to still enter the inner loop again. We're going to reset j back down to 0. Okay, and we're going to 0 is less than or equal to 2, right? So we're going to enter, and we're going to print an asterisk again. Okay, increment j. Okay, 1 is less than or equal to 2. So we're going to print another asterisk. Increment j. 2 is less than or equal to 2. Enter, print another asterisk. Okay, then j is going to become 3. 3 is not less than or equal to 2. We're going to leave the inner loop. We're going to print a new line character. Okay. Then I becomes 3. 3 is not less than 3. 3 is not less than 3. We're going to leave the outer loop, and we're done. All right, and the program terminates. So if someone entered 3, we're going to have a pyramid that looks like this. Okay, which is exactly what we were going for. All right, so the key thing, this one's a little bit different than the previous example because the key thing here is the inner loop is dependent on the value that changes, right? Is dependent on the value that changes from the outer loop, effectively causing the inner loop to iterate one more time at every time it goes through the loop. So first time through, it only iterates once, then twice, then 3 times, right? That gives us this, allowing us to print 1 asterisk, then 2 asterisks, and then 3, okay? All right, so we're going to stop there. And we will provide opportunities for you to practice this on your own. And we will follow up in a different video to do a more larger example applying a bunch of concepts that we've learned thus far.